So, hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 21 of Geeks for Geeks from the day December month. And we have a hard level question in front of us. It's called Candy. So, let's see what this question is. Uh, as you can see, we the inputs first. The We are given a rating array basically, and its length is basically called n. Okay, so we are given two inputs. One is n, which is the length, and the next thing is the array, which is also integer array, right? And then we have written an integer as the output. Now let us see the question, which will make more sense now. So they are saying that there are n children standing in a line. Each children is assigned a rating value given in the integer array rating. So this rating is basically the array rating given here is basically the rating of the children standing in a line. Okay, so you are given children in, yeah, you are giving candies to these children subject to the following conditions. Okay, so each children must have at least one candy. Children with a higher rating than its neighbor get more candies than its neighbor. Return the minimum number of candies you need to have to distribute. So what they are trying to say, see, a number of children are standing in a line, right? So each children is assigned a rating. So what that means is, suppose one children are in that line, that means it will have a left neighbor and it will have a right neighbor, right? And each of them will have a ratings. So what they're trying to say is that children with a higher rating than its neighbor get more candies than its neighbor. Uh, Try to understand this fact very clearly. For example, see this. If I talk of this one has only one neighbor, which is two. Okay, that means this is the rating first of all. The children with the rating 1 has only one neighbor who has a rating 2. Only these two are related. Remember, the children with this rating and the children with this rating are not related. Though they have a rating given, but they are not related. The rating applies only to the adjacent ones. Okay, that's what they are trying to say. Children with the higher rating than its neighbor get more candies than its neighbor. Okay, so you have to distribute candies in such a way that the children get more candies who have higher rank compared to that of its neighbors. Okay, that's what they're trying to say. And remember, while doing that, you just need to ensure that see, don't see only you need to ensure the ratings of the neighbors. Okay, for example, a neighbor has a rating of 1, and the element which we're talking about has a rating higher than that. So yeah, then you will have to relatively manage the candies, but you have to do in such a way that the minimum number of candies you have to, yeah, ensure that the number is still minimum. Okay, for example, if yeah, as you can see here in this case, uh, this particular rating is lower than 1. Okay, this particular rating is lower than 1. That means I can give any number of candies to this, but at the same time, to ensure that this is always higher than this, that the number of candies you give to this child is always less than the candies I give to this child. That's what you need to ensure. Okay, so let us see what we can do. So what I wanted to highlight is that this particular child and this particular child, you cannot compare. You cannot see the magnitude of the candies given to these two child, because see, though they have ratings, but we don't have to do anything with them because they are not adjacent. As simple as that. That's what I wanted to ensure. Okay. So let's see how to solve this question. So one thing might have seen is that they are saying at least one candy should be there for each children, right? So that's why I'm creating a candies array. First of all, I'm creating a candies array and initializing all of the for let's clarify what my thinking process here is. See, in this candies array, I will be storing how much candy should I allow to each of the n children. So what will be the length of the candies array? Obviously, it should be n, right? As you might have seen by now. And what are the values I'm initially I'm initializing it with? I'm initializing it with 1, because it's clearly mentioned that at least one has to be there, right, for each children. Next, what I'm doing is see my thinking process. It's very simple one. See, there can be two kind of neighbors, right? The left neighbor and the right neighbor. For each of them, we'll have to deal separately, right? So first, I'm going to deal with the left neighbor. So this loop will ensure that children with a higher rating than the left neighbor get more candies than the left neighbor. So when I say the left neighbor, what it means, for example, I'm at the ith index. I have to deal with the I minus 1th index. Okay, and that's what I'm trying to do here. Okay, so remember one thing. For this particular that is starting element, there is no left neighbor, right? So we will start with this particular element, that is the 1th index. Okay, so I'm starting with 1 and I'm going till the n minus 1th index. Okay, so what I'm doing, I'm just trying to ensure that for any I, if the rating of I is greater than the previous children's rating, okay, previous child's rating, what I need to do, I will simply add 1. See, whatever candies I had given to the previous child, I will just add 1 to it, and that much number of candies should be given to this child. Please start to understand what I'm doing. See, this is the comparison of ratings, and this is the allocation of candies. Please make this point very clear. ratings of I, if it is greater than the ratings of the previous child, what should I do? See, previous child I have already allocated some candies, right? This is a for loop. So those index are already covered, previous index are already covered. So whatever candies I have allotted to that, a plus one should be done and allotted to the current child. As simple as that. Once this loop is over, we will trace it out. See, we will trace. I have already traced it. I will show you that. But let us first, theoretically go inside the code. See, as I mentioned, this is for the left neighbor. Now I have to do the same thing for the right neighbor. What I'm doing here, I'm ensuring the same thing. Let child with the higher rating than the right neighbor get more candies than the right neighbor. So how should we do? Obviously, the thing is very clear. Now, right neighbor, when I say obviously this particular element will not have a right neighbor, so I have to start from this this thing, that is the second last element, and I have to go till the first element. That's what I'm doing here. I'm starting with the second last element, and I'm going till the zeroth element. When I mentioned -1 here, so basically this is how the for loop in Python works. If I have mentioned -1, that means it will go till 0. Okay, as simple as that. And this -1 is mentioned because we are going in an active way. For example, n-2, n-3, n-4, and till 0. That's how it is moving. Okay, so that we are doing. What we have to check, if the rating of I is greater. See, we are checking the right element, right? So if the current element I, the comparison should be done with I plus 1th element. So if the rating of I is greater than the rating of I plus 1th element, what I have to do? See, here and here there is slight difference will come. We'll see, talk about that as well. But for now, let us just understand what is happening. If rating of I is greater than the rating of I plus 1, then candies of I will be, whatever candies is allotted to the I plus 1th element plus 1. But remember, there is a one trick here, because see, they have clearly mentioned that we have to settle it with the minimum. Okay, so here we did that because that was necessary. But because by the time we come here, we know that we have already done this step once. Okay, so that's why we are adding external condition here, that if candice is already greater, for example, see, this is the rating comparison and this is the candice allocation, right? If the candice is already greater, then no need to add one to it directly. Okay, whatever is the candice, you can let it be like that. Okay, try to understand. If the rating of I is greater than the rating of I plus 1, but the candies with I is already greater than the candies of I plus 1, then no need to change candies of I. Okay, no need to do anything, because candice of I is already greater, so you can leave it just like that. Okay, leave it just like that. And if that is not the case, then this condition will not work. You have to come to this condition, in which we are simply adding one to the next element's candies, and we are adding that to the ith element. As simple as that. And finally, as I mentioned, this array is for storing the number of candies we are distributing to each child. That's why I have written the sum of the candies. Now coming to the tracing part of it. First we will try to trace, like, each for loop. Yeah, so see, this is the array given to us. Okay, this is the array given to us. I hope my screen is clearly visible to you. Next, we are ensuring, see, we are going right by that. Okay, first we will start with this element. Okay, see, remember, the first element will never have a left neighbor, so I'm going to start with this element. Okay, now I will compare the 0 with this. Okay, so please focus the numbers given here. I will compare 0 with 1. Okay, definitely 0 is less than 1. Okay, so no steps are needed. Okay, now coming to the, so it will also remain 1. Okay, initially all of the ratings are going to be 1, right? uh, okay, I think you will have confusion here. Just a second. Yeah, so I hope these things are clear. See, this is the ratings. Okay, and this is the candies. I hope now things are slightly clear. And this is the rating and this is the candies. Okay, so we are going to trace only the candies part. Okay, and not the ratings is anyway going to remain the same, right? So see, initially ratings will look like this. Okay, then the comparison part will begin. Okay, this 0 will be compared to this one. Okay, since 0 is anyway less than 1, we will not do anything. That's why, as you can see, this after end of the first loop, this element remains as it is. It was 1 only before the for loop also, and after the, see, this whole thing is after first for loop. This whole thing is after second for loop. Okay, what is the first for loop? This is the first for loop. This is the second for loop. Okay, I hope I am making sense to you. So yeah, after the first follow, it will remain the same, because 0 is anywhere less than 1. Now come to this part. 2 is definitely greater than 0. So I have to ensure that the candies allocated to this particular, this particular, which has one candy initially, should be greater than whatever candies allotted to this particular child. Okay, so that's why I'm doing whatever candies is here. I'm simply adding one to it and allocating it to here. So this is the situation after the first for loop. Now we'll start with the second for loop. Okay, see, in the second for loop, see, I'm having 0 here and this is 2. 0 is definitely smaller than 2, so no, again no change will be there. This 1 will come here as it is. Okay, Now come to second case. This this particular one is definitely greater than this 0. Okay, that means definitely again you have to change. Okay, so what we'll do, whatever is the value here, add 1 to it and write it here. So this will become 2 again. Okay, there are cases here like a max of these things I've taking, but in this case those don't apply. We'll simply add 1 to it and we will keep it. Okay, this is the final distribution of candies. Okay, so these are all candies array. Okay, this is the rating array because comparison will be done in the ratings array and the allocation will be done in the candies array. Okay, as simple as that. So this is the final answer. How the candies will be distributed. A sum of this is written in the final answer. So I will quickly run this and show you. As you can see, the outputs are matching with expected output, and you can segment it on your for your satisfaction. As you can see it, it works. So yeah, friend, that was all for today, and see you tomorrow. Thanks a lot.